All right, we are continuing with our area review, starting on number 15. Determine the area of a rhombus. So we know all the sides of this rhombus are 15. We know that piece is 25. Remember that in a rhombus, you have 4 triangles that are all exactly the same, and you have a right angle here in the middle. So you can use trigonometry to find your D1 and D2, so that way you can divide it by 2 to find the area. So I'll call that A and that B. And we can even draw the triangle outside of here, so that way we can do a little bit more math. So it would be the sine of 25 equals A over 15. And the cosine of 25 equals B over 15. And these are calculator problems. Multiply both sides by 15. So 15 times the sine of 25 is 6.339 for the value of A, and then the value of B is 15 times the cosine of 25, which is 13.594. I guess 13.595 technically. That's a 9. Okay, so if we know that, then you can say that your diagonal 1, we'll use the A's, so it's A, and this piece is also A. So it would be 6.339 times 2, which is 12.698, multiplied by diagonal 2, which would be B and B again, and B is 13.595. So your whole diagonal 2 is 27.19 divided by 2. Multiply the 2 together. So 12.678 times 27.19 divided by 2 is 1.72.357. All right, let's continue on with number 16. Find the area of the perimeter of the kite. So with this kite, remember that kites, like rhombi, have a right angle here in the middle, but all the triangles are the same. Now this triangle is the same as that one, and that one is the same as that one. So we can do Pythagorean theorem to find our diagonals. We know this one. This diagonal, which we can call it diagonal 1 if we want, would be 15 plus 24, which is 39. But we do have to do Pythagorean theorem to find diagonal 2. In a kite, there's always one segment that's cut in half, and in this case, it's the one we're missing. So let's set up our Pythagorean theorem. 24 squared plus x squared equals 25 squared. And if you're good at your Pythagorean theorem, you know that this is also a Pythagorean triple. You get x squared equals 49. So x equals 7. So that piece is 7, which means your whole diagonal 2 is going to be 7 plus 7, which is 14. So your area is 39 times 14 over 2. And you get 273 for your area. Now for your perimeter, you got to add up all the sides. You know that side's 25 and that side's 25. We're going to have to do Pythagorean theorem again with the 7 and the 15. So 7 squared plus 15 squared equals c squared. This is not a Pythagorean triple. So 7 squared plus 15 squared is 274. And then again, it doesn't tell me that I'm allowed to approximate. So I got to think about 274 and if I can reduce 274. I know that 274 divides by 2, but I really have to think about the perfect squares, if it divides by any perfect squares. And I don't really think it does. I think 274 can't be reduced. So C, the other missing side of the kite, has to be the square root of 274. So your perimeter, you would add up 25 and 25, which is 50. And then you would say the square root of 274 plus the square root of 274. So 2 times the square root of 274. All right, this next one, determine the area of a regular nonagon. Nonagon has 9 sides, in case you forgot. So whenever you're finding the area of a regular polygon, you divide it up into equal triangles. I'm just going to draw one of those triangles. Now, it says the perimeter is 36 inches, which is cool because I have to do 1/2 apothem times perimeter. I know my perimeter is 36, which is super great. But I need to know the apothem. Remember, the apothem is from the center to the edge. It's also the height of that little triangle that you draw. So I still have to do some trigonometry, unfortunately. So my apothem is there. Let's first figure out each side. So if I take 36 and divide it by 9, that would tell me the side measures, which means each individual side is 4 units. So from here to here would be 4. Cut it in half would be 2. I don't believe this is a special triangle because when I take 360 and divide it by 9, I get 40. 40 is not a special angle, but that is the angle on top of this triangle, which means that piece is 20 degrees. So now I can say, I can do a tangent to figure out the value of the apothem. The tangent of 20 equals 2 over a. Now remember, this is one of those situations since you have a in the bottom. Technically, you would multiply both sides by a first. And you have a times the tangent of 20 equals 2. Then divide both sides by the tangent of 20. So you have 2 divided by the tangent of 20. And that's what you pop into your calculator, which is 5.49495. So 5.495 is your apothem. And then from here, you can do one of two things. You can find the area of this triangle and then multiply it by 9 because there's 9 of them. Or you can do apothem times perimeter. Since I already know the perimeter, I may as well just do apothem times perimeter. 1/2 5.495 times 36. You could go ahead and do 36 divided by 2 if you want, and just do 18 times 4.95. And that gives you 98.91. All right, next one. Determine the area of the shaded region. So this is a situation where I'll find the area of my entire circle, and then I'll take out the pentagon. And that will give me the kind of goofy shape on the edges. The radius of the circle is 20 inches. So draw in your center. That measure is 20 inches. So you can find the area of the circle pretty quickly. Pi r squared. So pi 20 squared. 20 squared is 400. So you would say this is 400 pi. Now for the area of the pentagon. So again, we divide this up into nice little even triangles. So 360 divided by 5 triangles is 72. When you draw in the height, you end up cutting it in half, which is 36. 36 is not a special angle, so we are going to have to do trigonometry. We need to know both the apothem, this measurement, and we need to know the side. And technically that's half the side. So we have to do both sine, cosine, and tangent. Well, not tangent. So let's set up the sine of 36 equals s over 20, because that's the radius of the circle. And we're looking at that being 11.756, which means this whole side across the bottom, we double that number, and we get 23.511, which means one side of the pentagon is 23.511. Then we got to find the apothem. So cosine of 36 equals apothem over 20, with 20 times the cosine of 36, which is 16.180. So 16.180. So if each side of the pentagon is 23.511, multiply it by 5 to get the perimeter. Which is 117.555. Multiply that by your apothem, which is 16.18, and then divide that by 2. And you get 141.9795, so 98. In this situation, you really can't have an exact answer because you would take the 400 pi and then you would take out 141.98. Since we use trig, we can't really have an exact answer because trig is always an approximation. But we could leave it there. Or if we wanted, we could multiply by the pi and say 400 times pi and then take out the 141.98. And you get 1114.02. Either way. And the final problem on the review, find the area of the equilateral triangle, assume C to be the center. So this is kind of an easy version of the previous one. There's a lot less work involved. Find your middle angle, 360 divided by 3, which is 120. Conveniently, when you got your apothem right there, it divides the 120 up into 60 and 60, so you have a 30, 60, 90 triangle. So that's 5 root 3, and that's 5 root 3. Then we can do one side is 5 root 3 plus 5 root 3, which is 10 root 3. So you could do apothem times perimeter. Your apothem is 5. Your perimeter would be 3 times 10 root 3, which would be 30 root 3. And then divide your answer by 2. Don't go to your calculator for this, because you can divide 30 by 2 and get 15. And then 15 times 5 is 75. So 75 root 3 is your answer.